So hey, sorry about the mix-up in the schedule. I can't read directions. I'm Dan McKinley. Nice to meet all of you. I'm visiting from Los Angeles. So I was an early employee at Etsy, and I worked there for 7 years. Worked at Stripe for a while. Co-founded an X company. Along the way, I've talked to a lot of different companies who are interested in continuous delivery. And after I left Etsy, I had this idea that you could take the tools that we used there and just like drop them into another company and get them on the golden path. And in my experience, after actually having tried to do that a few times, is that's not the case at all. And I think one of our mistakes when we talked about continuous delivery there was that we talked about it with an emphasis on the tooling. Continuous delivery is not a set of tools that you can buy or fork, or at least it's not just that. And I think all of the work we did about that, all of the speaking we did about that, was important to give the movement credibility. But I think what we failed to communicate clearly was what it was like to live with the system and what it was like to keep it working. And so that's what I wanted to address. So one of the key things that made the system work was we were really trying at all points to get the most out of all the engineers that we had. And we were working backwards from two goals. We wanted to ship a lot of code, and we wanted to ship a lot of code very safely. And the other thing that we were doing the whole time was we were really trying to keep a grip on the sense of community responsibility, a sense that everybody had a stake in production, everybody had a stake in fixing production when it was broken. I haven't seen a lot of material about how you go about organizing a high number of safe deploys every day. It turns out that it's mostly a problem with humans. It's not a technological problem. So how do you even get to the point of deploying 40 or 50 times a day? Well, we got there on purpose. It was a thing that we did intentionally, and it went like this. So at the outset, there were a lot of obstacles to shipping very often, which we had to get rid of. We had to actively destroy pieces of process to even get going. After a while of that, there was an epoch where we got much faster at deploying very rapidly, but as we were doing that, we were still adding new people to the system all the time. So it's one thing to have 10 people deploying 40 times a day. It's a different thing altogether to have 100 people deploying 40 times a day. And so as we were doing that, we had to put in a lot of extra work to just keep the system working. So at all points along the way, there were things that didn't work. There were times when the system broke down entirely, and I wanted to put together a narrative of what that was like. I was there up until the point we had about 150 people deploying. Beyond that, you might need different things. So like I said, at the outset, we had to actively destroy some process. And namely, most of the things we had to actively destroy were things that were prophylactic. So the point of certain pieces of process was to stop problems in production before they got to production. So a good example of that, I can tell a story about it. In 2008, Etsy's engineering founders parted ways with the company, or some other euphemism to that effect. And those folks had meant well. They also were gatekeeping production really hard. And so the team that was left, we hadn't been allowed to touch production, and we were about to be expected to touch production a lot. And there was no production monitoring of any kind. So we were out to sea. My reaction to that when it happened was to start writing integration tests using Selenium, that web driving toolkit that Zenefits used to break the law. I used it to write integration tests. It seemed like a sensible thing to do because we needed some way to know if we were going to break production before we shipped code. And it was a thing that I could do with nobody helping me. The thing that I eventually realized about this was that when you're writing web driving integration tests, it's kind of like writing a multi-threaded program. Like, things have to wait for other things. It's complicated. This is not like a domain where human competence is estimated to be super high. And so even if you get competent at it, if you write enough tests, there's some likelihood of every single test just breaking. There's some innate failure rate. So if you have enough tests, it's always broken. And I reacted to that, and we reacted as a team to that by deleting all of the tests. The realization we came to is that the whole point of the tests is to give you more confidence at the point that you press the deploy button. And to the extent that they're giving you bad information, failing when nothing's actually wrong and things like that. It's doing the opposite of that. Tests are one way to gain confidence in making changes to production, but that's all they are. They're just one way. Ramping up code really gradually is another way to gain confidence that your changes are not going to break things. Deploying code in smaller and smaller pieces is another way to have higher confidence in changes that you're shipping. Every line of code has some non-zero probability of breaking production, and so if you add up enough of them into a single deploy, you're just going to break production. There's no way to avoid it. And the other thing about that is that the fewer lines of code you have, the more reasonably you can inspect it and see whether or not that change set is going to break production or not. Another thing we did a lot was deploying code to production so that users couldn't see it, but so that we could see it and play around with it. That's another way to gain confidence. And over the subsequent years, we did write a lot more tests, but they were unit tests that ran very quickly and did not have a flake rate and did not use the network or do anything that would cause them to have a big flake rate. And tests that finish quickly are a very good confidence builder. You may have tests, but you must have monitoring. So you can write an infinite number of tests or have an infinite number of other prophylactic measures, but you're only going to asymptotically approach zero problems in production. You're still going to have problems in production. So when you're building a website, you should prioritize knowing that something is wrong, and you should prioritize your capacity to go and fix the thing that's wrong. Preventing problems is a secondary problem to that. So another piece of process that we had to destroy was Baroque source control rituals that we had built up before we started doing this. I will summarize that by saying that Git is bad. Git is not bad, but it was created to support software that's not anything like web software. The Linux kernel is one example of the thing that Git was built for. You have to support many concurrent versions of the Linux kernel at once, and you have to apply patches to them. And that is not how a website works. The website has a current state, which is the code that's running on it, and in addition to that, all of the data and things that it interacts with. It has a current state. It doesn't make a lot of sense to think of a website as having a version. GitHub, likewise, is oriented around building open source software, and it's really good for that. But there's no reason to expect that the things that you do on GitHub should automatically make a ton of sense for building a website. The tendency among engineers is to start with GitHub and then bang on some tools and bring all of the cultural baggage of GitHub to bear and then hope that you get working software in the end. And that just doesn't work. We eventually came to the realization that the website is a different domain and we should do different things with it. Namely, we should conceive of the website as this living thing that we're just changing constantly. It's not a thing with discrete versions that we jump around on. So what we did was we treated the production code base as also the development code base, and we branched within code so that we could do things like turn on features for admins or not. Those are things you might attempt to do with source control, but we did them with code. So after we made those leaps, we started to be able to deploy many more times per day, but then other problems arose as we did that. The story so far has been about destroying pieces of process, but those were pieces of process that we destroyed intentionally on purpose as a whole team that we talked about those things. It's a different thing entirely for individuals to decide that they're just not going to do process. And the major reason that happens is that the deploys are just too slow. So if the deploy tooling is not fast enough, there's probably some faster way to get changes out, and people are going to do those things. They're not doing those things because they're coming to work hoping to do a bad job. They're not doing those things because they're evil. They're doing it because people follow the path of least resistance. That's just what they do. So you want to make the right way to change things also the laziest possible way to change things. You're also occasionally going to need to change things in a hurry, even if you don't want to do it. You could have an actively exploited SQL injection attack on the site, and you're going to have to use that fast path, even if you don't want to use the fast path. You don't want to be in the situation where you're using the fast path in crisis mode. You want the fast path to be the normal path. That's how you know it works. You use the fast path all the time. So do you really need to run a white space linter in the critical path to production? Maybe you don't. You want to make the compelling way to deploy the right way to deploy. So eventually we got people treating deploys as routine, but that came with its own problems, which is that if you ship code only extremely rarely, then it's a notable event. If you ship code many times every single weekday, it's not a notable event. That is like a tautological series of sentences, but it has dire implications, and that's that people will not treat them as special. They'll stand up from their desks and wander off. The mountains will call to them. They'll go on a walk and get coffee. They'll just do it. It's entirely possible to automate shipping code from when you put it in master to just have machines push it out to production. We didn't do that, and I don't think it's a good idea. I can explain that with an analogy to self-driving cars. So a while ago, Uber YOLO'd this self-driving car trial in San Francisco. It ended very abruptly after this video surfaced of a self-driving car just steaming right through a red light with pedestrians in it. It's important to note that this was not literally a robot car. There was a human sitting in the driver's seat. Human didn't intervene. Uber's PR reaction to this was to say it's the human's fault for not intervening, but that is exactly wrong. The right way to think about this is that the human and the car are a single system. The things you do to automate the car affect the human. The human's attention lapsed because the car made it seem like it was automated enough that the human did not have to pay attention, but that's not the case. The things you do with automation affect the humans. You have to treat them as a holistic system. So automating deploys is very much like that. You can deploy the code, but you can't always predict what it's going to do to the database or what have you. It's a very good idea to have a human there to put their foot on the brake or whatever the correct analogy is in deployment. So making people actively press a button to deploy, I think it's a very good idea, even if 99% of your deploys are entirely routine and automatable. In the rare case where something goes wrong, you want the human there awake and ready to respond. Automation that only mostly works is a lot worse than no automation at all. So another problem we ran into as we ramped up deployment speed was that people skipped steps while they were deploying. So if you deploy from a command line tool like this is all of the context you have when you're deploying, which is bad because this is all of the context that you need. You need to know, like, did the tests run and did they pass? Are there other people's changes in master right now that I'm shipping that I need to know about? Is the site currently working or is it on fire? And so on. So I think that since you need all of that context, although I know that people love command line everything, I think that what you really want is a web cockpit for deploying things. The reason for that is that a web cockpit can surface all of that latent status to you. And they can lay out a workflow that comprises multiple steps, so you can't enter one command and then forget to enter the next one. The other thing about these is that they're more accessible to people in departments that are less technical. So you can have people in support deploying knowledge-based changes using the same system. You can have designers deploying CSS changes using the same system, and all of that stuff is great. Another thing to keep in mind when you're doing a high number of deploys every single day is that deploys are not special, and that's not just a problem for the person who's deploying. It's also a problem for anybody in the organization who might have to react to deploys. So at my first job, the way we deployed code was we showed up on Saturday at 6 in the morning, and then we spent several days or possibly a couple of weeks, fighting fires. And, that was brutal. It was terrible. I did not enjoy it. But the one thing you could say about that is that everybody knew it was happening. You were completely aware that deployment was happening. And brutality is not a great ethos, but it is at least an ethos. So if you take away the brutality, you need to come up with some other way for people to know that deployment is happening. You have to build that awareness on purpose. You no longer get it for free. One thing you need is an easily accessible status page. It says what's happening with deployments right now, and given any timestamp, what was deployed at that point. Drawing lines on your graphs is another great thing to do, so that if you see a graph go sideways in production, you can go back and see, oh, there was a deploy just before that, that probably explains the graph going sideways. A thing I've seen other teams doing a lot is siloing their deploys and notifications and other things into different team channels very aggressively, and I think that's a bad idea. What you get when you do that are incidents where Team A in their Slack channel deploys a thing, and then Team B in their Slack channel gets a bunch of alerts going red, and you lose the obvious connection between those two events. So what I think you should do is you should coordinate in a single push channel and take that as far as you can. You want to keep the shared commons where deployments occur, where changes to the system occur. So those are some of the main hacks that got us deploying very rapidly, very fast, but eventually the marginal returns on that stuff starts to even out. So you add more people to the system, but you can't make a single deploy much faster. You can only fit so many of them into a single day. But you keep adding people, so something has to give. One approach you can try is to make the day longer, and I definitely did that for a while. Tech employees rise very late, in my experience. So if you get up at the crack of dawn, you can ship a bunch of code. That's a really bad idea. I don't suggest it. You could split up the deployables. It's another thing that's in vogue. But if you do that, you take on a lot more operational debt and other baggage, which I will stop myself from ranting about. But I think you should resort to that only when you've exhausted other options. So other options include, well, if we deploy a lot, we can look at the things we deploy, and we can figure out if there are any patterns we can extract from that and make into faster lanes. A good example of that is if you're doing feature flag-driven development right, a lot of your changes look like this. They're just changes to a single feature flag, ramping a thing up, turning a feature on or off, or what have you. Those are changes that are really safe, or if they're not safe, you can reverse them very easily. So we can take those out, and we can put those into a different pipeline that skips the tests or maybe some other things, and runs in parallel to the other side. Another thing you do a lot, if you dig deeper, is if you're developing in the production branch, you're shipping a lot of code that's just dead weight. It's either conceptually or literally like this. It's just code that's not executed at all. And those are obviously pretty safe deploys because you're not changing any live code. So you can just invent a silly convention around that. We just said if your code is not executed in production, just put the word dark in all caps at the start of your commit message, and then anybody deploying will know that, okay, I can just ignore that diff. It's fine. I can go forward without talking to that person. So if you have a situation where 4 people are trying to get code out, maybe 2 of them are dark deploys like that, and you can make those 4 deploys into 2 deploys. But those things help, but they have their limits. So to keep sustaining your deployment velocity, you need to get people talking to each other. You need to enable a situation like this where you have 2 people both making live changes to the system, and in the event that something goes wrong, those people need to know that they're working together and be able to have a place to talk to each other. And that's pretty complicated. This was a place where we actually did write a decent amount of code to make it work. We wrote a chat bot called Pushbot. Someone was nice enough to write a clone of it and put it on NPM and maintain it, which you can find today. So conceptually, we have a lot of people in our shared space, our shared push channel, wanting to get code out at any given time. We decided to arbitrarily just divide them up into train cars. So I think the number of people in a train car varied over time and is arbitrary, but let's just say we put 3 people in a train car. The car at the head of the train is deploying. All of the rest of them are waiting. The push bot is coordinating that, saying, this train is the one at the front, and you guys are deploying. New people can hop into the channel at any point, join the train at the caboose, or they can add a new caboose to the train if the caboose is full. Within the train car that's deploying, 1 person is designated by the chatbot to be the person in charge of that deploy. They're the person that's going to press the buttons. So the first thing the train car does together is they all push their code to master, and then they tell the chatbot that I've done that. I've pushed all my code to master. I'm done doing that. Then the chatbot will ping the deploy leader and say, hey, everybody's ready. At that point, you can deploy to QA. Once the code gets to QA, everybody goes through some manual validation step, which could be different depending on exactly what you're shipping. You could be curling endpoints or clicking on things or what have you. But once you've done that, you tell the chatbot, okay, I've manually verified my changes. I'm good to go to the next step. Deploy leader gets a ping that says, hey, everybody's ready to go to the next step, and you press the deploy to prod button. And that's the way it goes in the usual case. In the event that something goes wrong, you can use the chatbot to say, hey, something has gone wrong. The great thing about the system holistically is that when something goes wrong, you have a large group of people in channel who are in some state of paying attention, who are all there available to help. So those are some of the social hacks that got us somewhere north of 100 engineers deploying code every single day. I wanted to give a sense for what that felt like and what it felt like to evolve alongside a continuously changing continuous delivery system. I don't think that those are that's not a set of instructions per se. It's a toolbox. There were other less important things in the toolbox that I didn't talk about, but they're just tools. The details of your situation are going to be different. So if you're working on a Mars rover, your tolerance for failure in production might be different than ours, and the exact set of trade-offs that you want to make are also going to be different. But what I think is really interesting is that none of the things that we did were technical challenges. They were social challenges. Some of the solutions to the social challenges involved writing some code, but it was never really complicated code. It was very straightforward, like tools to get people to talk to each other. The hard part was maintaining the sense of community ownership over the system. The hard part was not like writing an AI system to do deployment or anything like that. So because in order to deploy software, you have to write it first, what often happens is that people bring lots of different kinds of baggage to the table and then do those things in development and then think about shipping later. They bang on the things they do in development with tools and then hope to get working software out the other end. But there's no reason to expect that that approach to it should work or result in anything that's good. The approach that does work is keeping in mind what your goals are. Ours were shipping a lot of code and shipping it very safely, and what your operational constraints are, and then working backwards from those things to the things you do in development. If you're trying to increase developer velocity and it looks like a really interesting technical challenge, you might want to stop and ask yourself if you're getting into the weeds. The tendency, once you've programmed yourself into a really deep hole, is to just keep programming, and I would suggest that you should not try to program your way out of every situation. So that's my spiel. I think we have a little time for questions.
Bring it, right? Knows how to do it and sell a company too. We have a few minutes for questions.
PHP unit.
Post.
Oh, the question was, post Selenium, what tools did we use? So the way that went was we really only wrote unit tests for a long time, and that was mostly PHP unit. Like every language has got some like unit testing, mocking thing. So that's what we used for a long time. Eventually, we did reintroduce some integration tests, which we ran after deploys. So after the deploy to QA step, integration tests would run against that environment for extremely critical path things where it made sense to have a team of people maintaining those tests and keeping them working. Because it really is, I underestimated the amount of effort involved in that. It was no joke to keep some good integration tests working. Some weird stuff happened with that where the integration tests created registered users because registering was considered critical path. Simultaneously, someone was writing anti-fraud code that banned people that signed up from single IPs. So there was a day where we came to work and all of the employees had been banned from the site because of the interaction between the smoking tests and the anti-fraud stuff. Be careful with integration tests, I guess, is the takeaway.
Of information. So thank you. Big round of applause.